Brief review to help.
Joke. We need a joke. We need a joke.
Can't just stop. Let's do this. Let's keep it clean. PG 13.5. Let's keep it in bounds.
You knew it.
Who's there?
Interrupting cow.
I know.
That's too late. Play show. You got a joke.
Restart the video.
Yeah.
Oh, I got one about Obama.
I wasn't
No, you
ready.
didn't.
You get it.
No, it's a ritual.
Alright, do it.
Okay.
I have a lot of black jokes.
No, it doesn't.
You gotta be driving me nuts.
That was the joke.
But they're not funny.
Alright, go, baby. Just go.
Obama?
Oh yeah, I got one.
Too late, play.
You know how to catch a polar bear?
How?
With Coca-Cola?
Oh, it might work, but no, you go to the Arctic, obviously, and you find a nice flat piece of ice, and you want to drill a big hole in it, and then you take frozen peas, you know what I'm talking about, like in the bag,
Yeah.
frozen, and you line them up around the outside of the hole you drilled, and when the polar bear comes up to take a pee, you kick him in the ice hole.
So sick.
Third grade.
It's third grade.
Fourth grade level.
I like the driving me nuts one. That was pretty solid.
He's disappointed. I can tell
I
you.
was disappointed.
Clearly disappointed.
You spent too much time thinking about it.
Who's filling the bill?
He's just like, oh, that's it. Okay.
That's a good one.
I wasn't subscribing for that joke.
That's a dislike on the video for that one.
Graphing, well, let's see. What do we know about graphing? If
If it's the first number, it's
and transformations more. X squared, remember what those look like?
it's a
Parabola. Parabola. What about x to the third? Weird. What about absolute value of x?
V.
What about 1 over x?
That's asymptote.
It's the
Asymptote.
Sure.
oh.
Sometimes horizontal asymptotes can be crossed. What about 1 over x squared? Did you see that one last year?
You probably did.
Janica, weren't you in STEM race class in my 4th period last year?
If this is 0, 0,
6th period, not 4th period.
I was in 4th period.
it's basically the same. Well, it should get taller faster and lower faster.
So it's just like more extreme.
It's just more extreme, yeah. But over here on this side, will it be possible to get a negative value for y?
No.
If you plug in a negative value for x, you square it, it becomes positive, right? So it just brings it up here.
Whoa.
That's about it. Okay, now shifting these. So like if I told you to graph 1/2, or y equals 1/2 times x minus 4 squared minus 1. Do you know how to do it?
Move it.
Yeah.
Move it to 4 and
Down 1.
then it's
And the y is going to be divided by 2.
twice as big. Twice as
That's a good place to start. Go doing this whole, remember inside here was left and right, outside here was up and down. So that'd be right 4, down 1. What does that tell you? What point on the graph of that?
The vertex.
The vertex of a parabola. If it was x to the third, what point would it be?
The middle. The middle.
The very middle. It's called the point of inflection. What would it be on an absolute
The vertex.
vertex? What would it be here?
like in between them, like not on the line.
It's where the asymptotes cross.
Yeah.
That would be,
Is there a
Right
fancy
there.
math word for that?
no, you don't think so. Right? No, not, vertex is just like corners of parabolas or absolute values.
The end. Yeah.
Angles, yeah.
What's it for the last one?
Same thing here. It's where those cross. Part of the reason that works is like on this one, say it was 1/2. Oops. Say it was 1. Well, we wouldn't have a half in front. Say it was 1 over x minus 4 minus 1 with a 2 down. No, that's different. Damn it. Anyway, say if it's like that. If you plug in 4 for x, what do you get for y?
0.
No.
Oh, wait.
No.
-1.
4.
4?
Yeah.
4 in for x.
4 minus 4 is 0. What's 1 divided by 0?
Nothing.
Can't do it.
-1.
That's why the vertical asymptote's there. So the vertical asymptote gets shifted to the right 4. Alright? Okay. So it doesn't matter which family it's from, the shifting still works the same. You guys remember?
Oh, it's still the center point.
Yeah. It's just a different point for each graph. So that one, that's going to be my vertex. What now?
You have to figure out how fast it goes up.
How can I do that?
8's the half, so wouldn't it be twice as fast?
Yeah, it'd be twice.
Yeah, but
Twice.
we don't. It'd be wider.
It'd be twice as
It's
wide.
going to be wider.
Twice, so it's twice as slow, I guess.
So what can you do? Just, how are you going to graph it?
Divided by the answer by 2. Plug in points.
Plug in points, yeah. Sorry, dude, just plug in a few. Doesn't take long. I picked 0 a lot. 0 minus 4 is -4 squared, 16. Half of that's 8 minus 1, 7. Boom, right there. I can really easily get another one. What do you know about parabolas and their shape?
That
It's
once
same
across the
distance.
vertex, it's the same
Symmetric,
distance.
right? So if I'm up here at 7, 1, 2, 3, 4 away, I can go 1, 2, 3, 4.
It'd be 8.
Yeah. Boom.
Boom. Good enough. You can plug in a couple more points if you wanted to get more accurate, but that's generally what you do, right?
Yeah.
And that's for any of these, when there's a number in front, or when there's a number added on the inside, or when there's a number added at the end. You know how to do all of those?
Find the point and then plug in
Yes.
numbers.
Okay, so if I said graph, let's get a little harder here. Let's graph 1 over x plus 1 minus 1.
Okay. So
Jeez.
there's an asymptote.
Where's the vertical asymptote?
-1.
-1, because if I plug in -1 for x, it doesn't work. There's my vertical.
Yeah.
Can you see that?
No.
Okay, I'll just draw it solid. There's my vertical asymptote, or you could, hey, that's left 1. What about my horizontal asymptote? What
Down 1.
-1.
-1, so it'd be down 1, right? Yeah. So there's my horizontal.
But there is your asymptote.
Now, what? Very good.
Plug in points.
Just plug in a couple points.
Start with 0.
Easy.
1 divided by 1 is 1.
I like, plug in 0 for x. Yeah, that's a good one to start with. Because 1 divided by 1 is 1. And
Minus
1
1 is 0.
Boom.
Hey, boom. It's going to go shoo. And then down here, it's going to be the same thing. You can plug in more points if you need to, but that's the general idea. Okay, now we're going to get to the challenging ones. What happens if you get this?
Oh, what's the other?
It would be to the left 4.
See, you would think that, right?
But it has a 2 in
But it's not.
It's to the left 2.
It's to the left too. Why?
It's 2x.
Because that makes the bottom 0,
Yeah.
2x.
Okay, yeah.
Son of a mother. Yeah, whatever the vertical asymptote goes, of whatever I plug this number in, I better get a 0 on the bottom. So yeah, it actually ends up be right here.
But the positive 1 is still the same. That's where the
The
vertical.
plus 1 is still the same, is it?
Yeah. It's still the horizontal.
It's on the outside. So you'd be there, and then you can plug in some points.
0.
2.
Oh, you wanted to do it? I was going to do that.
Oh, then move on.
I was just going to be like, yeah. You know how to plug in points. I don't need to plug in points. But there are some crazy ones. I wanted to get. I guess we don't have to do the crazy ones today.
Let's keep it simple.
Keep it simple. I forgot the numbers I picked already. All you're going to do is draw graphs. 1, 5, 7. 1 you can do, 5 you can do, 7 you can. Oh no.
Oh no. Coco no.
We got to have a method here, and I don't really even know it. This is honestly the first year we ever taught this. Not gonna lie. So like 2x minus, let's go plus 2 squared minus 2. Look at all those 2's. That's a good problem.
Wowzers.
2x plus 2 squared minus 2.
Am I wrong? Am I wrong to assume that it's to the left 2 and down 2?
Left to 1.
You are wrong to assume that it's to the left 2 and down 2. That is correct.
Okay.
No, it's left. It's left 1. Left 1 down 2.
Left 1 down 2.
To you.
And it's parabola.
Just choke me now.
Couple different ways to do this. You can, you know what? I'm gonna cheat. I'm gonna use the example below just in case. Not feeling very smart today.
Neither am I.
All days.
Every day.
Let's do that one.
Now it's 4.
That way I have the answer and I know I'm not being a moron.
Okay.
Okay.
It's left 4.
Is it left 4?
Left 2.
Right.
Right 2.
Oh wait, it's negative. It's negative. Yeah.
Right 4.
It's right 4, down 1.
Why are you guys so
I don't get that.
Right 2 down
What?
1.
Caleb, there's a squared, it might be a different answer.
Oh, wait.
Yeah.
It's right 2 down 1.
It's right 4.
What happens to the y values? Let's
It
think about our
goes down one.
Let's think about our tables or like our points from the last one. To the y values, isn't it just everything on the outside?
Yes.
So it's going to be down 1.
Yeah.
Yes.
So our vertex is going to be somewhere down here at -1, right?
Yep.
Yeah.
Okay. Let's do that right now. Vertex, something -1.
Yes.
How do you figure out what happens to your x values?
Or you can plug in -1 to get the x value.
Did you do the prime thing?
You do the prime thing?
Yeah, but the prime thing is
Basically what you guys were just doing.
Yes.
You guys have the wrong answer. 4.
Yes.
Remember you go, which one goes on which side? You go x
Prime.
1/2 x prime
equals
minus 2 equals x, and then you solve for
Yeah.
x prime. So you'd add 2, 1 divided by 1/2.
You weren't here for that.
Yeah.
It's all on YouTube.
It's on the
Add me at Aaron Hopkins 37 or whatever his thing is.
It's just Aaron.
It's just Aaron
Hopkins.
88.
Like, subscribe.
Want me to put it in the screen?
See, the weird part about this is the 1/2 in front of the x. It doesn't. It is gonna. The vertex will be to the right 4, but not all of the points on the whole parabola is shifted to the right 4.
English.
You said to do this, right? You take that inside part. You go x equals 1/2 x prime minus 2. Right?
So you add 2 to both sides.
Add 2, so you get x plus 2 equals 1/2
And you
x.
multiply by 2.
So it's 2x plus 4. So all of the x values get multiplied by 2, and then you add 4 to them. So the point, if you're talking about your vertex, originally it's 0, 0. If I put in 0 for x, my new vertex is at 4, comma, whatever y is.
1. In this case, it's 4, 1.
In this case, it's 4, -1.
Oh, yeah,
It's not just going to be a normal parabola, though. It's going to be stretched. So at this point, I would just plug in some points.
0.
0, that's a good one.
-2 squared.
0, -2 squared is 4. 4 minus 1 is 3. 0, 3. Boom.
And then since we know how parabolas work,
And then since we know how parabolas work, 1, 2, 3, 4. 1, 2, 3, 4. Boom. And look, it's pretty wide.
it's like a bowl.
Do not use a graphing calculator.
I'm scared.
Why not?
Because you're going to...
Because we want you to teach you do it in your head.
In your
So just in case there's an EMP, just in case there's an EMP on the United States, there will be no electronic use. So they have to do all paper.
So you have to graph your parabolas.
That's legit why I feel like teachers don't let you use any electronics during testing.
Yeah, because not like electronics are going to dominate our future at
There's hard, crazy ones, but we might not even do them. I don't know. Okay, here's what you got to do.
We use them.
Here's the plan for the week.
Oh, we're talking like expanding.
Now, we have 20-something minutes in this class?
26, yes.
Okay.
I'm going to assign this crap.
You either use the same Pokemon to one, and that'll give you some.
Huh?
Or you
Monday.
use green cube.
He said do Monday, because he's leaving anyway, so.
The rest of the week we will be reviewing. We might take a quiz. You might miss a quiz. Shut up.
Clayton.
Pokemon, shut up.
So then you're like,
You go suck.
no.
I got him, don't worry.
Keep me checked on.
Probably take a little quiz on this transformation stuff. and review for everything for a test.
Yes.
Next week.
What? Somebody give me the goat.
Yeah.
It's just over this, or is it like?
No, like over inverses
All
and
the things?
knowing how many apples you get from your trees if you plant a certain amount. Lots of those problems. And what else? All that crap. We'll go over that throughout the week. Sorry.
You want me to stop the video?
No, here's what you need to graph.
So many.
Oh yeah, there's.
So we should get like a blank paper that has this on there?
I can give you graph paper if you want, like this.
Yeah, that'd be nice.
Yeah, just like.
What ones are we graphing?
You are doing.
We're gonna get draft paper.
Graphing.
What, recombination?
What in pre-calculation?
What in math calculation?
What in math nation?
How are you gonna do 17? You're gonna have to remember some first semester stuff.
We say we do, but then we don't.
Like factoring?
I'm not drafting.
Oh, we're gonna have to
Factor.
I would complete the square, personally. Do complete the square, get it into vertex form.
reverse back forward.
That's enough. I was gonna add more.
Yes.
Wait, what's this?
Do you want me to stop the video now?
Yeah, stop the video.
Okay, please like and subscribe. Thank you for watching.